move away from karaoke and move back to our diagram here if we can. Okay, so I know it has to equal north. So this is going to be my resultant, is going to go straight north. Okay? So it says the avalanche is traveling east 5 degrees south. How do I draw that, please? Yeah, go ahead. Yeah, okay, so we're going to say, this is going to be the first thing we're adding. Here's 5 degrees. That's 10 kilometers per hour. And I'm going to call that A for avalanche, okay? Now, here's the other thing that's tricky. I'm going to add Bailey to that. So where am I going from where to where? Yeah, it's not quite a hypotenuse, it's not a right angle, but I know what you're trying to say. So Bailey is going to be this right here. Oh, goodness. Bailey, you got away from me there. That's going to be 30. Let's get rid of the R. Okay. So is everyone feeling sort of okay about where that came from? So what I'm saying is I had to add together the avalanche plus Bailey's direction in order to get pointing towards straight north. Yeah, go ahead.
Like, why 10 divided by 8?
Oh, it's not 10 divided by 8. I just couldn't find a good spot to put it. A stands for avalanche and B stands for Bailey and R stands for resultant. Okay. Let's do this is, I think for this one, I'm probably just going to use trig instead of components for this one. So we're going to say, we got to find which way Bailey is heading. So what angle are we looking for here? Yeah, go ahead. Well, again, draw whatever you can, right? The idea is generally if there's two vectors, I try and draw a big triangle like this first. That's what I try and do. Components, we'll get into those for the next example too, right? Components are good if there's like multiple things going on or if things are relative to each other. But again, just try and draw, I don't know, I wish there was an easy answer, say, do it right, okay? All right, now what else can we put in here before we solve? There's a few other things we can try and put in here. What else can I put in? Oh, there's nothing else I can put in?
The resultant
angle.
being Nora. You can put that.
Sorry, go ahead.
The left angle, use that line.
Yeah. So what I'm going to do is I can call this angle right here, this big angle there, 95. Okay, so what am I actually looking for Bailey? What am I looking for in this question?
The right angle.
Yeah, I'm looking for this one. This is what we're eventually looking for. And then we got to worry about north, south, east, west, and all that stuff. Okay? Is everyone okay with what I'm looking for there? Brendan, all as well? Brendan, you got a nice hair on you too, if you don't mind me saying that. You got it. Sorry guys, I hope it's not awkward when I say that, but like, look at me, I'm jealous, okay? I hope you know that. These aren't put downs, these are like compliments, huge compliments. Okay, how do I solve for theta? I'm going to draw a little triangle just so you can make it out a little bit easier here. Okay, this is what I have. Back to grade 10, how do I solve for theta? Sine law, thank you. One person is awake here. Guys, I know it's hot in this room. I know it's winter outside. I know you wish it was a snow day today. Sorry, Billy, I'm bringing it back to you. I thought you should be happy. Look at all the snow that's on the ground.
No, I just want to be.
See, you are snowboarding.
No.
Right here, you're
Not
snowboarding.
any question.
We are going to use sine law, in fact, but we have to solve for beta first. Can someone other than Bailey tell me why I have to solve for beta first in this question? Go ahead,
I
Darren.
don't have a side length opposite theta.
Yes, and just so you guys know, Spider-Man's coming out tomorrow for word problems, because I see a lot of people here just passively sitting and watching, okay? So we're gonna solve for this one first, then we're in 180, you only need to get the last one. So I'm gonna say sine beta over 10 equals sine 95 over 30. Sine beta equals 10 times sine 95 over 30. And beta equals, I lost my page here. 19.4, is that right?
Yep.
Can we confirm that? Okay. Can someone other than Bailey and Derek and Chris tell me please how to solve for theta? Awesome, go ahead. Very good. So theta equals 180 minus 95 minus 19.4. I can't do that in my head, I don't think. 105. I can't do that in my head. 114.6. Somebody help me here? Thank you. All right. Are we done this question? We are very, very close, but not yet. We don't quite have her heading. What do we have instead of her heading? What angle did we just find? The angle between what and what? Uh-oh. Yeah,
Between her and the avalanche.
between her and the avalanche. There's all we found. So remember, we have to find between north, south, east, west. Okay. So how are we going to find? How are we going to do this? Find between north, south, east, and west. Okay, go ahead.
What I did is I dropped a triangle underneath A.
Okay.
Like I dropped it, so I continued north down, and then I took west off of the bottom.
You're talking about this here, sort of deal?
Yeah, and then because the top of that one, because you know it's 95.
Yeah.
So that means that the top one would be 85.
Okay.
This is the right angle.
Very good.
You know that the heading would be 5.
Yeah. The other way to do it, if you don't like that explanation, which I love, by the way, you could have just went zzz, 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 and got 5 as well, too. Okay? And it also likes the Z pattern, okay, right? So you could have done that as well, too. Okay, so then therefore, Bailey must aim, so then plus 5 degrees. Bailey must aim at west 70.6 degrees north, or north 19.4 degrees west. Okay. Okay. Do we feel sort of okay about this word problem thing? So I think basically from here till the end of the unit is all word problems, every question. Right? Yes.
Is there significance that 19.4 was?
See, because I was wondering about this.
Like if you
I was sort of wondering, if you try and make a big triangle, you mean like this, you're saying? Because that's 19.4.
you extended the angle that looks like.
Yeah, and that's what I was doing, Carrie, because that's 19.4. That's right. This would be then whatever the big one is, right? That's going to be 65 points. No, it's not 65.6. That's 70.6. I don't think there's really a significance to it. You know what I mean? So that's what I just did for that, and then subtract 65. I don't know. I don't think so. I don't think so, but well, I guess there could be though, right?
You look at the,
Yeah, I guess there could be if you just do it like this. It would be a right?
Yeah.
With a big triangle. Right, so the question was, this is 19.4 and the answer is 19.4. The other way to look at it was, I know the beta is 19.4 and to get the same thing for the north, which is cool too. Math's cool, it works out, that's good. Chris, you're making me tired. You're making me tired right now. Okay, one more example, and we'll call it a day. Standard trade assignment. Or two more, only one more example, shoot. Okay, sample 4. Yeah, let me just do one disclaimer before I continue this question here. Probably there'll be a Superman question on your test. Not that I love Superman, I don't, but he's one of the few superheroes that can move at 500 kilometers per hour through the air. I like Spider-Man. We'll get to Spider-Man when we get to trade. Okay, Spider-Man will be all over trades because he swings and he repeats and, you know what I mean, there's angles for webs and stuff, okay, right, but for people moving in straight lines very fast in the air, it'll be him, okay? So we're going to say Superman heads northwest at 500 kilometers per hour. He encounters a wind of 120 kilometers per hour, which is a big wind, from 25 degrees north of east. Find the resultant ground velocity. Okay, now I want to talk you through this and explain all about what all these things mean. Okay, let's envision, so I'll get to a regular question here, so I'm too excited. Okay, let's envision Luke as Superman. Okay, Luke is flying through the air at 500 kilometers per hour. There's going to be a wind blowing him through the air, so he's going to be pushed to the side. What the ground velocity means is, if I am looking up at Superman from the ground, how fast is he going? Okay, Superman wants to go at 500 kilometers per hour, that's what he's traveling. 500 kilometers per hour, but he's getting pushed. Right? I know he's Superman, so he wouldn't really get pushed, okay, but he's getting blown off his direction. If you're standing on the ground looking up, how fast is he going? That's what we're saying, that's the ground velocity, is from someone on the ground. What vectors are being added in this question, please? You guys play along, please play along, okay, because this is going to be a miserable class if nobody plays along. Go ahead, Austin. So this is going to be Superman. He's going 500 kilometers northwest. What does northwest mean? Somebody other than Austin here. What does northwest mean? Jason, go ahead.
45.
45, directly between north and west. And this is going to be my aspect for Superman. All right. This is the part that always gets people. If a wind is blowing from 25 degrees north of east, what does that actually mean? Yeah.
So it's blowing west, but since it's north 25 degrees out east,
Yeah.
there's that up east and it goes up.
Right on. Okay, so so this is what you're thinking here for this. I'll draw and move. This is how the wind is blowing like that. It's blowing from 25 degrees north of east. Okay? So if you're standing looking at the wind, you turn 25 degrees north of east and it's hitting you in the face. Okay, that's what it's saying. Now, unfortunately, you can't add a vector to look like that. I'm not sure, make that a little bigger. Okay, the vectors do not add like that. How does the vector add instead? Okay. Yeah, so I'm going to move that W, hopefully, and perfectly. Oh, almost perfectly. Down like that. and perfectly answer. So everyone see what I did there? Even though it's coming from north 25 degrees east, but it's not, like, because you're adding it, it's going to be added in that direction. Okay, so if you're looking for distances and all that stuff, let's draw this a little bit differently. I'm going to erase that. There's my W vector. That's 125. Using Z pattern again, that's going to be west 25.
120 or 125?
Sorry, west 25 degrees, that's supposed to be, sorry. But it's still 125 is the distance still?
Oh, but it's 120.
120, oh goodness. I got too excited, sorry. Thank you. Okay, somebody new here that hasn't talked in a long time. So you guys know who's there. What is my resultant going to be? Where's my resultant going to be? From what to what? Please go along. Please go along, Nathan. Can I pick on you?
That. Right there.
There, there. Okay, I hope from there means starting there and ending there. Okay. Now the trick with these wind questions, so this is going to be my ground velocity. The trick about these wind questions is that you have to move. Is everyone okay with why that wind moved? Right? Like you're looking, the wind is blowing you in the face, which means it's going to push you back the other direction. Okay, so if you're standing here, the wind is coming, but it's blowing downwards in that direction. And that's an awful looking straight line. So there's G. Okay. How do we solve for G? Yeah, go ahead. We're going to use cosine law again. I'm going to redraw this. You don't have to, but I'm going to just to make it easier to see. There's a 120. There's a 500. There's your magnitude of G. The angle in there is going to be 45 and what is that, 55? 45, 55? 45 and 65, which is 110. Whoever said that.
How do you know that?
How do I know that's right? Okay, so back to what we were doing before here again. This right here is going to be 45. Okay, that little chunk there is 45. If this is 25, making that an angle, then so that's going to be 55 or 65? 65. Right, so that little chunk 65 and 45 makes. Okay. Yeah, question?
The way I did it was I had at the bottom of Superman's vector, at the tail of it,
Yeah.
I had an east dotted line,
Okay.
and then couldn't use like a C shape with the top of the
To
vector.
get this, you mean?
Yeah, to have
Yeah.
the angle there,
Yeah.
and then you just subtract 25.
Yeah.
Okay.
That'll work too again. As long as you get 110, there's many different ways to do it. I hope you don't mind me saying this, Alistair. Unlike you, I like the Z pattern. I'm all about the Z pattern, so I prefer to use that one, but you can use all the other rules too. Yeah, Brendan, what?
How'd you get 65?
Okay, so I'll just draw a big over here, okay? So we had, so this is 25 there, right? You okay with that? So then this is a right angle. Right, so that is 90 minus 25 is 65. Okay? Yep. All right, so let's go through this here, cosine law. Can I get somebody please, Teresa, to recite from the cosine law, please? On the right, go ahead.
Like a quarter of cosine?
I can probably just give me this one.
So 120 squared.
Yeah.
Plus x squared.
Yeah.
Then minus 2.
Yeah.
Cos.
Thank you very much. Okay, so I hope to hear everyone doing this right now. I'm going to click on Calvin here in about 1 minute. Sorry, Calvin, I clicked on you too much this year. Yes, question?
So, how do you know that like the other angle is 45? Like
Oh, okay, just the same, but I just use that here. No, okay, too much, no problem. So I know that this is 45 down here, right? If you just do a right triangle, that means this is 45. And then another right triangle means this 45. Okay. Or you can use that if you want, that's what I was saying, you can use that over. All right, Colin, were you able to get an answer by any chance?
Yeah, if you square it, it's 552.66.
552.66 until we confirm. And that's kilometers per hour. Now, before somebody says Superman is indestructible, the wind wouldn't blow him, you're right. Okay, but go with this question as a physics question. What angle do I need to solve here? Now, think really hard, and the regular crew is out, sorry, you're out. What angle am I looking for, the left or the right? Left?
Right.
You're always remember the angles with the things going like this, right? So because the vector's pointing in this way, it's always from where the vector starts. Okay? So we're going to call this theta, and our heading, that was a 45. Our heading equals theta plus 45 degrees. Okay? Because you're starting at 45. Okay, so how do I solve for theta? Sine law, thank you. So I'm going to say sine theta over 120 equals sine of 110 over 500. Anyone get that? Anyone get that, please? Alex, sir? 11.8, I'll call that. Wait a sec, is that right? Did I get the angles messed up again here?
110 should be opposite 552.
Thank you.
552.7.
See, I'm just not on that pilot, sorry. Is it still 11.8? Therefore, from the ground, Superman appears to be flying uh, 552.66 kilometers per hour north, 56.8 degrees west. Good, because we want that from 9:45 to it. I'll write homework on the board in case you need practice on these. It probably wouldn't hurt to do a few of the component stuff. Okay, word problems we're delving into tomorrow as well. So my homework here is that's some of the choice assignment. Homework is page 343, number 6, 8, 9, 14, 350. Number 6, 7, 8, 9, 14, 20. Okay. Now, before you guys freak out and say, well, that's so much work, the choice assignment is not long, as I said to you already. Okay? I gave it to you yesterday and you finished it in one night. Okay, so, yeah, it's doable. If there's questions on it, and I'm sorry I have to do this too because I hate being this type of teacher, we'll go through all the questions on Monday. Like if there's things you want to go through and weren't able to, because again, I want to do another full lesson, I promise tomorrow. If possible, okay? If you guys want to take one, pass it on, I appreciate it, thank you.